So I guess like the first topic is like solar cost versus reliability, right? What is the solar cost? Like this data gives an idea from 2010 to 2020 in terms of residential solar, commercial rooftop solar. Also in the next page, it gives an idea for the utility scale, 100 megawatt fixed tilt, and utility scale with a single axis tracker for 100 megawatt. So you can understand from 2010 to 2020 means what's the price. Like if you look at 100 megawatt fixed tilt solar plant, the cost has been reduced to 20% of the cost in 2010. You can understand the cost of solar install capital investment has reduced from 100% to less than 20% in just 10 years. Same scenario for a single axis tracker as well. You can visibly see these numbers, right? So it is not so much in the residential, it's not that much in the residential, but still the price reduction is drastic, and commercial also like it's drastic. Means that this one single probably slide gives an answer like why solar is going to be the future. So this is a capital investment. If you compare the capital investment of solar, if you compare the capital investment of the solar is the cheapest capital as of now compared to any other sources. Per megawatt basis, if you compare the capital investment, compare any other sources like hydro, thermal, gas, combined cycle, diesel, wind, compare any other sources, capital investment perspective means solar is the cheapest. Okay, so we have talked about the capacity perspective. Then the next question obviously is what about the levelized cost of energy perspective, right? Like there is a second perspective which we need to probably look at. So I sincerely request you to visit this page, nrel.gov.pv/levelized cost of energy calculator. So this gives you levelized cost of energy, that is per kilowatt hour, like what's the dollars or whatever maybe your local currency. This NREL page. I guess like you might be aware of NREL. If not, make yourself aware of NREL. So if you go to this page, you can find out like all the information. What's the technology which you are using, what's the package type, what's the system type, what's the location which you are using, what is the DC to AC ratio which you are giving, what's the baseline which you are giving. Like all this information if you give, like this will give you a beautiful report. Kindly ensure that you are visiting this NREL website for understanding the cost of it. So typically cost of energy, levelized cost of energy for an Indian scale is less than 2 rupees now for a large scale grid connected systems, less than 2 rupees. If you're going for maybe a rooftop or like commercial rooftops, etc., then this cost will be higher. It depends, and that's precisely what you have seen in the previous slides. This is a capital investment. Still, if you look at the capital investment, there is a clear difference. Capital investment of rooftop solar in the residential is like three times capital investment. So for a large scale plant, the levelized cost of energy will be like much lower, whereas for a rooftop it will not be that cheap because that's a small capacity. So like the global best benchmark is in Indian rupees, it's 1 rupee. Like that's a global best benchmark, which probably the world is moving towards at this moment, right? This is the Indian power sector performance for May 2022. India has generated 125.04 billion units energy from conventional and 19.3 billion units from renewables, which approximately mean about slightly 16% of the energy comes from the renewables. Remaining 84% of the energy comes from conventional power plants like thermal, diesel, hydro, nuclear, gas, etc. So this also precisely gives a message for a solar this month of May, like you will be having like high solar, and despite of that, like what's the renewable penetration which you are able to meet is like less than 20%. So this is May 2022, like 125 billion units from renewables, 19.3 billion units from 125 billion units from conventional and 19.3 billion units from renewables, which includes both wind and solar. So the total energy consumption what we had in the month of May is like 144.3 billion units. If you count like what's the renewable percentage is about like 13.3%, right? Which means like about remaining 86% came from conventional. Which means though we have probably talking a lot, still there is a long way to go. Still, what's the energy which we are consuming assuming if you are sitting in India at this moment, means you may be using laptop or mobile to watch this webinar. 86.6% of the energy produced to power your laptop or a mobile or a fan or air conditioner or washing machine comes from conventional. So when we are talking about the electric vehicles, probably we have to talk essentially this as well. All right. So coming back, let's look at from other perspective also. This is only from the energy perspective. Let's look at from the installed capacity perspective. Installed capacity already India has 113 gigawatt renewables, and if you want I can share the link as well, right? So out of 402,817 gigawatt, right? 402,817 megawatt or 402 gigawatt. This is the total installed capacity. 402,817 is the installed capacity as of 31st March in India, and out of which 113,226 megawatt is renewables, which means from the installed capacity perspective, the renewables is 28%. Just probably at two different messages here. From the installed capacity perspective, already renewable is about 28.1% of the installed capacity. Out of 400 gigawatt, about 113 gigawatt comes from renewables from the installed capacity perspective. But from the energy perspective, the 28% of the renewables means only 13% of the energy, not an apple to apple, 28% of the energy, which also gives another interesting information. If we want to meet higher percentage of the energy by renewables, say example, if I want to meet 100% of the energy from renewables, then what should be the installed capacity which we should have? So let's probably look at maybe some interesting informations on one of the projects, NEOM green hydrogen project. I'm not really sure how many of you have heard about this project, right? This is probably from Air Products, right? So this is the largest green hydrogen projects which is expected to commission by 2026, which has about 1650 megawatt wind. 1650 megawatt wind. The project is at the initial stage. It's in Saudi. 1650 megawatt wind, and it has about 2400 megawatt solar and 400 megawatt storage. And Air Products Aqua are probably taking care of the process side, and L&T has backed the order for the balance of plant, which is substations, renewables and wind, right? So it's a huge project, and you go through this, and if the project successfully probably commissioned, this will be having very limited grid connectivity, just about 200 megawatt connectivity from the grid which they are taking, which is there in the NEOM. So go through this for more information. An amazing project to watch in. So we have our own contribution to these projects. So that's the reason why which we are talking about. Yeah, NEOM, I guess and there are probably small level the renewable 100% renewable capacity which we have already done. Even when I have worked in one of the project in 2015 in India, 2 remote villages in Maharashtra, we have powered the entire villages purely by solar. But one thing which we need to really look at other side is what's the commercial aspects, what's the economics. When we have put up 2 villages electrified purely by solar, it has a storage systems, and it is not really making commercially attractive, right? And probably means solar cost is coming down. But when we have seen this equation in the Excel sheet as well, 28% of renewable installed capacity generating only 13%. And if you probably want to have maybe one more information, I can show you how unreliable it is with respect to the solar. Let's probably pick it up. One of the 90 megawatt or 80 megawatt measurement which we have done for for the solar plant, right? You can see the current. It's 2 p.m. Every 5 minutes measurement goes on. You can see here, look at the variation in the current. Look at the variation in the current. It's a night, of course, it's 0. So you can see the variations, right? It's definitely not reliable. It's not definitely reliable. And in order to make this intermittent renewable resources reliable, you may need some other energy storage systems. And you might have heard this other projects in India where Greenco put up 900 megawatt hybrid, which is wind, solar plus battery, pumped hydro, right? And Renewable is constructing this 300 megawatt plus energy storage, home power and so forth. So these are all probably, what we are looking at. Only if you compare the cost of electricity, levelized cost of energy, and unreliable solar power versus controllable other sources which would come from diesel, thermal, hydro, etc. I mean, solar is cheap, but if you want to make the solar reliable, you need obviously battery energy storage systems. So like solar plus battery energy storage system is going to be the future, right? That's probably the statistics, another number. And like, I mean, what about the solar forecast? Like looking at 2017 and 2021 and like where we are in 2022. So the world has installed about 167 gigawatt solar in 2021, and that is, I mean, expected to increase to 228 gigawatt in 2022. So I mean, 167 gigawatt is what we have installed, and like the plan is about like 228 gigawatt in the year, ongoing year. So I mean, this is a historical data, and probably blue is a low scenario, and this is a medium scenario line, like, and the high scenario. I mean, if we go probably travel in the medium scenario this year, like we will install about like 228 gigawatt across the globe, right? That's probably the forecast of the solar. Now let's probably putting up all these things like solar is cheaper, and probably though it's unreliable, but like the forecast is this much. So means when you have like large solar, when you keep adding the solar, I mean, what's the biggest problem which is going to happen is during daytime the solar is going to generate, and probably after 4 o'clock or 5 o'clock this is going to drastically reduce, and probably the conventional sources like thermal expected to ramp drastically. So that's going to be the biggest challenge, that is defined as like duck curve. If you Google it, duck curve, like means most of the countries this is applicable. You can understand. Grid stability will be in question. Means when we are keep adding the solar, the biggest problem is the minimum short circuit current, not increase in short circuit current. In fact, like it is a reduction in the short circuit current. Why short circuit current will be less when the renewable is added? Because if you're adding a 100 megawatt solar plant, let's say if you're 100 megawatt solar plant, compare with a 100 megawatt thermal plant. This 100 megawatt thermal plant will have an XT double dash impedance of about, like, say, example, 0.2 typically, right? And transformer impedance may be 0.12 or 0.13. So approximately that will inject 3 to 4 times the rated current as a short circuit current. If you take conventional generators like diesel, thermal, hydro, etc., conventional physical generators, they will inject typically 4 per unit as a short circuit current. But if you take solar inverters, they will inject 1.1 per unit as a short circuit current. Because this is a power electronic device, they will contribute only 1.1 per unit. And that too, if there is a fault close, inverter do not have a low voltage right through capability. The inverter do not have a low voltage right through capability. Then probably gone case, this inverter itself will drop. So means when you are going and keep adding this intermittent resources solar, the biggest challenge is not the increase in current, but you have to deal with the minimum short circuit current. And I guess like NEOM project also, they will definitely feel the same heat because it's purely renewables. There is no like rotating machines. That means that's not a strong grid. Your flow current and your load current is almost the same. Then how do you detect the fault, right? Like typically we use instrument transformers. That is current transformer, and connected to the relay to detect the fault by means changing the current from flow to the like short circuit current. That's a huge change. Load current is like 500 amps, whereas the fault current is 10 kiloamps. So you will detect that as a fault. But pure renewable alone environment, that's not going to happen. Your flow current and short circuit current is almost going to be the same. That's going to be the biggest challenge when it comes to the pure renewable grids. The biggest challenge what you will be facing is reduction in the short circuit current and sensitivity issues of the overcurrent protection than increase in the short circuit current. The variation in the solar is uncontrollable. It's intermittent in nature. So means we need to ensure that frequency is maintained constant across the day. So frequency control is going to be a difficult call. Probably 20 years back or 30 years back, what the load dispatch center operators has done is quite simple. All their sources are controllable, only the loads are uncontrollable. So whenever there is a change in the load, automatically frequency will change, and this controllable generators with an AVR and governor, like they will try to control the frequency and regulate the frequency by means of increasing or decreasing the generations. But now with an intermittent resources, load is not the only thing which is changing, but also the generation which is varying with respect to the solar radiation, or if it is a wind turbine with wind speed. Then it becomes like extremely tough call to control the frequency, and load dispatch center operators are going to face that challenge. And power quality harmonics, that's going to be another challenge, because if you have a synchronous machines that doesn't inject any harmonics, but if you have inverters or wind turbine generators with a full converter that's going to inject harmonics to the system. The reactive power capability of the inverters is not same as the synchronous generators. That's going to be another issue, right? Stability issue, right? That would be like, I mean, so say quite a lot of issues which we can expect, right? So why solar? Probably means to say this is data of, I guess, like 2019 data with respect to the job market, means to say across all the renewables. This is also coming from IRENA, I guess, like you might be aware of it, International Renewable Energy Agency. 2019, like total number of jobs which is provided across the globe, means compared to any other renewables, like the solar is at the top. So but question is like, what's the means if you look at the cost of solar, which is yellow here, like 2010 that is the highest, and probably 2020 that is the lowest, and it is further expected to go down. So nobody asks, or nobody's going to ask a question like why solar. Solar is going to be future because of it's cheaper. Of course, it might be green, but it's cheaper. That's the reason why it's growing. So what's the role of an engineer in solar plant design? So means when you are designing a solar plant, like you need to look at like quite a lot of aspects. One, what's the impact of this solar plant on grid, that you need to look at. What's the impact of grid on solar plant? That's the second aspect which you need to look. And you need to work towards minimizing the capital investment, and you need to work out enhancing the energy produced, and then you have to probably, I mean, what say, optimize the levelized cost of energy for 25 years, which is typically the lifetime of the solar plant. So what's the role of engineer who is at the design stage? We need to ensure that like capital cost is minimized, energy is maximized, levelized cost of energy is reduced, and probably the plant is running reliably and providing to an extent quality power, to an extent, I mean to say reliable power for like its lifetime. So that's all probably what we need to probably look at. So I have like maybe 3 different cases, like 1 2 megawatt solar plant which we have done, and other 50 megawatt solar plant which we have done, and other 300 megawatt solar plant which we have done. I'll probably come to the slide. I will open up this open up the single diagrams a little later, and I will show you like what can be optimized and like how to optimize all the stuffs. It probably takes time, no worries. Like, and like means to say what are the points which can optimize. Like say example, if you're optimizing the on-load tap changer range for a solar plant, that's massive task. If you're optimizing the transformer impedance and optimizing the short circuit rating of the switch gears RMUs, that's like another important aspect. If you're optimizing the reactive power compensation rating, that's another great thing. So means the role of electrical engineers at the design stage or an engineering stage is something great, where you can probably means for say enhance the quality of power by means of reducing the harmonics, by means of increasing the reliability, increasing the availability, increase the productivity. That means the actual energy generated per year, which you can increase if you have probably designed your power system properly. And like what are the simulation softwares which are available to assess what's the total energy which can come from this solar? Like there could be like quite a lot of softwares. So means also here the softwares which are available helping you to identify what's the total energy which can be produced by this solar plant. These are all energy evaluation softwares. If I'm putting 1 megawatt, how many units of electricity which I can generate? What's the revenue which I can make? Right? It gets a solar radiation as an input and decides what's the output. And this is precisely what we have talked about in our YouTube channel. So there are at least about 5 videos: grid connected and standalone solar plant design, grid connected and standalone solar plant design, grid connected and standalone solar plant design. Again, like 5 videos which we have talked about. Means what say all these 5 videos talks about like energy estimation using like PVsyst. Like that gives at least a preview, which videos has been updated a couple of years back, but that gives a rough or a fair idea of like how to estimate the energy using PVsyst. Right? These are all probably means to say energy estimation simulation softwares. Then probably let's go to the next slide. What about this simulation software? ETAP, DIgSILENT, PSSE, PowerWorld, or PSCAD. I guess like the SIMATE someone has talked about will come here exactly. What this simulation softwares will do? This simulation softwares help you to understand the impact of the solar plant on grid and impact of the grid on solar plant in terms of voltage profile, equipment loading, losses, short circuit current. If there is a fault in the grid, whether the solar inverter is able to ride through or not. Means if there is a fault, whether the solar inverter will support reactive power or not. Means what's the impact of the harmonics which is injected by this solar plant on grid? What's the resonance? Is there any impact of flicker? right? So all these things has to be evaluated using the simulation softwares like ETAP, DIgSILENT, or PSSE, or like any power system simulation softwares. And I guess like there are quite a lot of power system simulation softwares which are available in the market. So you can Google it, or probably if you go back to our YouTube channel, so we have talked about like advanced power system simulation software, real-time simulation using softwares. Like you can understand like much more onto that. Right? Like say example, there could be like plenty of questions to be asked when we are going for the solar plant. Means let's say whether to go for two winding transformer, three winding transformer, five winding transformer, string inverter, central inverter. What's the capacity of the inverter, right? So there are plenty of questions to be asked during the engineering stage. Means what say there was a debate for a 300 megawatt plant or a 1500 megawatt plant whether we have to go for string inverter or a central inverter. The cost evaluation you have to do. It has both has advantages and disadvantages. Like you have to look in deep. And now this solar plant has to come with the battery energy storage system, whether it is an AC coupled system or a DC coupled system. There's another debate. Right? Like it's all probably means what say the engineering stories which you have to probably means what say definitely means what say evaluate.